Right, here we're going to look at some examples on doing synthetic division. So synthetic division is a shortcut method for using division with polynomials or expressions. It's a way that you can quickly find a quotient or a remainder. So the way that it works is we're going to draw part of a box like this. Now, what goes into the box right here is your factor. The other thing that we can call it is your d of x term. Now what goes in the other side of the box is going to be the coefficients of your polynomial, or p of x. Once you do that, the other piece to synthetic that you need is the following. You'll take your first term, you'll draw an arrow down, and then you're going to give yourself your solutions bar. And then you're simply going to say that the bottom number times your factor goes underneath the next. Then you're going to add them vertically. So let's see what that means. So I'm going to go ahead and draw myself my box. Now, this piece here is my d of x, whereas this part right here would be the factor number. So here, x plus 2 means my factor is a negative 2. So the negative 2 goes in. And then you have to use the coefficients of your polynomial in descending order and in its completion. So if you look, my polynomial would have a 1, and then a negative 2, a 0, and a negative 8. We are then going to draw the arrow down and put our equation bar underneath, and we're going to go ahead and get started. We're going to drop that 1 down to the bottom. Essentially what this does is this takes your x cubed, which is what's represented up here, from an x cubed down to an x squared term. Okay? So here we're going to do 1 times negative 2, and it's going to go right here. So this is where we're going to put the negative 2. We are then going to do old school vertical addition. So we're going to have negative 2 plus negative 2 gives me a negative 4. And we're going to start again. Negative 4 times negative 2 goes right here. So this is going to be 8. Again, we're going to use old school vertical addition. 0 plus 8 is going to give me 8. One more time. 8 times negative 2 is going to be a negative 16. We're going to do old school addition. Again, negative 8 plus a negative 16 is a negative 24. Now what we're going to do is we're going to rewrite our equation. So this is going to give us x squared minus a 4x plus 8, which means this piece right here is your remainder. So your remainder here is going to then be minus 24 over the x plus 2. And that is going to be your divided term. We can also separate our pieces out and identify the fact that our q of x was x squared minus 4x plus 8, with your remainder being negative 24 over x plus 2. Alright, let's take a look at one more example. Now what makes this example different is the fact that here we're going to use imaginary numbers. Okay, so again, we're going to have our p of x on the top and our divisor on the bottom. So just like before, we are going to go ahead and we are going to open up our box and we are going to put in our factor, which in this case is going to be 3i. And then we're going to go ahead and put in our terms. So here this is going to be a 2, a minus 10i, a 5, and then the 8 minus 3i. Alright, so we're going to go ahead and set it up. Here we're going to draw this straight down. And now we're going to go ahead and do it. So we drop the 2 down. Just like before, we're going to take 2 times the 3i. That's going to give us 6i. We are going to do vertical addition. Negative 10i plus 6i gives you a negative 4i. Multiply that by 3i. Okay, so here what's going to go in is we are going to have 3i times negative 4i is going to be a negative 12i squared, which is going to equal 12. I squared is negative 1 times negative 12 is a positive 12. Here we're going to add them together. This gives us a 17. Then we're going to do, again, 3i times 17, which is going to give us 51i. So in this case, we have 51i. We're going to add these together using vertical addition. So remember, again, we're going to combine the I terms together and bring the constant through. So this is going to end up becoming 8 plus 48i. We started with an x cubed. We came down here to having an x squared, so let's identify our pieces. Here we're going to have a q of x, which is going to be 2x squared minus the 4ix plus 17. And then we're going to have our remainder. So r of x is going to be 8 plus a 48i divided by our x minus 3i is our remainder. So we can put it all together. Our polynomial would become 2x squared minus 4ix plus 17 plus our remainder, the 8 plus 48i all over x minus 3i. So there is everything you need to know to get started with using synthetic division instead of long division to divide out your polynomials. Okay? So if you have any questions, please let me know. If you have any problems that you would like me to work out, send those to me. I'd be more than happy to work them out for you and to help you along. Otherwise, I hope you had fun. I know I sure did. And I will see you next time.